Hello and welcome back to another video of the Brainy Heart. In this video, we'll be looking at one of the most interesting organs, which is the ear. To start off, we'll take a look at the physics of sound and how it travels to your ears and how your ear figures out what sound it is. And then we'll talk about the anatomy of your ear. So let's start off with some physics. So everything you hear right now is coming to you through the help of sound waves. So everything I'm saying right now is sound waves, and that's what you're hearing. And the job of your ear is to process this and send this processed message to your brain so it can be interpreted. The frequency and the amplitude of your sound wave that's going into your ears determines the pitch and the volume of the noise. So frequency is nothing but the number of waves within a given period. As you can see, this image over here has a lower frequency as there are fewer waves within a given period compared to this image over here. So when a sound wave has low frequency, your ear processes it as a lower pitch. And the opposite is true for high frequencies. So when the sound wave has a high frequency, your ear picks up a high-pitched sound. And then in terms of volume, we look at amplitude. The amplitude is the height from the middle of the wave. So this right here is the amplitude of this wave, and this right here is the amplitude of that wave. So as you can see, these waves have a lower amplitude than these waves. Like I said before, amplitude determines the volume of the sound. So a sound wave with a low amplitude will be processed in your ear as a softer or a quieter sound, while a high amplitude sound wave would be processed as a loud sound. So that's the basic physics of how sound works and how it gets to your ear. Now let's take a look at how that sound travels through your ear and how it's processed in your ear so it can be interpreted by your brain, and then you can actually hear something and store it in your memory if needed. So let's take a look at the anatomy of your ears. Let's say you hear something and that sound slowly makes its way over to your ear, and the first thing that the sound wave would encounter is your pinna. So the pinna is what others see when they look at you. That's the outer part of the ear. And then the sound travels through the auditory canal, and then the sound encounters the tympanic membrane, also known as the eardrum. And once the sound reaches the tympanic membrane, sound makes the tympanic membrane vibrate in a certain way. And this vibration changes from sound to sound, and that's one of the steps that help your brain figure out what that sound actually is. So once the tympanic membrane vibrates from that sound, that's the end of your sound wave. After that, it's all vibrations. So the vibration started over here, and now it's going to continue into the middle ear. So your pinna, auditory canal, and tympanic membrane were part of your external ear, and the tympanic membrane is about where the middle ear starts. And in the middle ear, you'll find three bones called the ossicles. And the first ossicle is the malleus, and then is the incus, and then is the stapes. So the vibration travels through these three bones and then gets to the oval window, which is right over here, and that is the oval window. And once that sound gets to the oval window, that vibration is sent to the cochlea, which is basically a shell-shaped organ within your ear, and the surface of your cochlea is made up of the organs of Corti. the organs of corti are basically hair-shaped neurons that fire based on the vibration. And this is where the process of transduction happens with your hearing. If you remember from the eyes video, transduction is where sensory input is converted into neural information so that the brain can understand it and interpret it. So in the cochlea, the organs of corti move in a certain way based on the vibration, and they move in different ways based on different vibrations, and create neural information which is sent through your auditory nerve, which is right over here, into your temporal lobe. And once it gets your temporal lobe, it's your brain's job to figure out what that sound actually is based on the neural information that it gets, and then react to it if needed, or store it into your memory. So hopefully your brain's storing all this information into its memory, and hopefully you can remember it later. But yeah, that's how the sound wave from over here gets to your brain. And not related to hearing, but a very, very important part of your ear are these semicircular canals. And these semicircular canals have a fluid within them that controls the vestibular senses of your body. And the vestibular senses basically tell your body where it is in terms of space. So when a person is doing backflips, it's the vestibular senses that tell the person where they are in space. And it is the vestibular senses that allow you to stand straight and not fall over, and it allows you to keep your balance when doing anything. And these semicircular canals and the fluids within them are the reason why you can do any of that. If not, you would basically be falling over randomly, and yeah. So that's the anatomy of your ears. But before I end this video, I'd like to go over two different types of deafness, and hopefully you know that deafness is when a person can't hear sounds. So, like I said before, there are two different types of deafness. And the first one is nerve deafness. And nerve deafness is caused by damage to your cochlea, or the organs of corti, or which are the hair-shaped neurons within the cochlea. And if anything happens to those, you're pretty much doomed, as it's really hard to fix them and they do not grow back. And if you don't have your organs of corti, then you will not be able to convert these vibrations that are sent from your tympanic membrane to your oval window to your cochlea into neural information that can be processed by your brain. And that's the reason why nerve deafness, it's really hard to fix, like I said before. But the other type of deafness, which is conduction deafness, is easier to fix or treat because conduction deafness is deafness caused by damage to any part other than your cochlea or the organs of corti. So basically anything from the auditory canal to your tympanic membrane to your ossicles, and sometimes even the oval window. And the reason why you can treat these normally through surgery. So let's for older people especially, the ossicles start to quote unquote wear out, and they might need to have them replaced, and that is a surgery and it can be fixed. So nerve deafness is caused when the sensory input cannot be converted into neural input for our brain, and conduction deafness is when the sensory input itself cannot reach the cochlea because there's a problem before it. And the conduction deafness can normally be fixed, while nerve deafness is harder to fix. Two quick fun facts about the ossicles that I forgot to mention while talking about the anatomy is that the first one is that those three are the smallest bones in your human body. And number two, They're also called three other things. The malleus is called the hammer, the incus is called the anvil, and then the stapes is called the stirrup. And that's because the malleus looks like a hammer, and the incus looks like an anvil, and then the stapes looks like a stirrup. So that was your ossicles, the ear, and your sound waves and the physics behind them. Hopefully you learned something new and enjoyed this video. Also, thank you so much for 300 subscribers. I'll continue making this content, hopefully more often now that my summer break has started, and hopefully I can get a video or two in every week. And yeah, thank you once again for the 300 subscribers, and I hope to see this channel grow a lot. This is the Brainy Heart signing off. I'll catch you later in the next video.